We're on lesson 3 of chapter 5, which is to solve multi-step inequalities. First we'll do just that, then we'll identify the number of solutions of inequality, and then we'll do a real-world problem. First we need to solve this inequality. Negative 0.6 times x minus 5 is less than or equal to 15. So this will take us multiple steps, and that's why they're called multiple step inequalities. We can do distributive property with this negative 0.6 times the x and then times the 5. So we have negative 0.6 times x, which would turn into negative 0.6x minus, then negative 0.6 times 5 would give us negative 3. So minus negative 3, which would just be plus 3 then, is less than or equal to 15. Less than or equal to 15. So now this turned into a two-step inequality. So we could subtract 3 from both sides to get rid of that. So we have negative 0.6x is less than or equal to, and 15 minus 3, which is 12. Then if I'm going to isolate this x, I need to divide by negative 0.6. And we'll do that to both sides. So that'll turn it into a positive 1x. Because I divided by a negative, I need to flip this then, like we learned last lesson. So greater than or equal to, and then 12 divided by negative 0.6 would be negative 20. So x is greater than or equal to negative 20. So if I plot negative 20 here, count by fives, I want to do a closed circle at negative 20, and then it's greater than or equal to, so I'm going to be going to the right in that case. So here's my closed circle, and I go to the right. Let's make sure everyone knows that I closed that, so fill in all the gaps, and there we have it. Here we have variables on both sides, so that's still a multiple step inequality. We have 6x minus 7 is greater than 2x plus 17. So I'd like to get all the x variables over here and all the non-variables over to the right. So I could subtract 2x from both sides. Then I could also add 7 to both sides to get rid of this minus 7. So that would turn into 4x is greater than 17 plus 7, which is 24. If I wanted to isolate the x then, I could drag this over here and divide both sides by 4, and that gives me x is greater than 6, and since it was a positive 4 I can leave this be. So if I make this number 6 and count by 2's, I can now plot an open circle at 6, and since it is greater than 6 I can head in the right direction, which means that it's greater than. So for these ones it says solve the inequalities if possible. So let's see what that means. We have 14x plus 5 is less than 7 times 2x minus 3. So if we rewrite this equation, we have 14x plus 5 is less than 7 times 2x is 14x, and then minus 7 times 3, which is 21. And we have a little issue here. We have 14x on both sides. So if I subtracted 14x from this side and then this side as well, I would have 0x plus 5 is less than negative 21. And I know that 0 times anything is just 0, so I'm left with 5 is less than negative 21. This is a false statement. So we're actually going to say there are no solutions to this because x can't be anything to make this statement true because there's 14x on both sides. And we know that 5 is always going to be greater than negative 21. Let's see if this one does anything different. We have 12x minus 1 is greater than 6 times 2x, which is 12x, minus 6 times 1, which is 6. So same thing with the 12x's. I subtract the 12x's from both sides, and that gives me 0x, which just is nothing. So I have negative 1 is greater than negative 6. Well, I know this would be a true statement. Negative 1 is greater than negative 6. So no matter what numbers I plug in for x, it's going to be a true statement as negative 1 and negative 6. So we're going to say all real numbers our solutions. So you can plug in any number you want and that would come out to a true statement. Let's look at a real world problem. A gas station charges $1.99 per gallon of gasoline if the customer also gets an $8 car wash. What are the possible amounts in gallons that you could buy if you also get a car wash and spend at most $20? So I always like to start with the inequality here, spend at most $20. So we could spend less than or equal to 20. The amount you're going to pay is that $8 car wash for sure, so it'll be plus 8. And then the amount of gallons, so let's do that in G, times $1.99. So 1.99 G plus 8 needs to be less than or equal to 20. So what's our range of gallons that we can get which would be less than $20? We can subtract the 8 from both sides here, and that'll leave us with 1.99 G is less than or equal to 12 now. And then we could divide both sides by $1.99. 12 divided by 1.99 is 6.03, and I'm going to round to the nearest hundredth here. So 6.03, so G, or gallons, needs to be less than or equal to, and we would say 6.03. Anything at or below this amount of gallons would still let me pay less than $20 for the total.